All right. Ready to dive into Docker? We're going deep on essential commands.
Yeah, and we've got a great resource for the top 200 most used Docker commands.
Like a Docker cheat sheet.
But we're going to break it down, not just the commands, but the logic behind them.
So you understand what's really going on under the hood.
Right, how Docker really works, so you can use it effectively. So where do we begin with all this command line magic?
Well, I guess before we can make any magic happen, we've got to make sure we're speaking the same language.
Exactly.
Oh.
Got to make sure we're using the right version of Docker. That's where Docker version comes in.
Oh yeah, like checking the Docker dialect. What else is important for setting things up?
Well, there's Docker info. It gives you a system-wide snapshot of your whole setup.
Oh, okay. Like
Yeah.
storage drivers, SIC groups, all that stuff.
Yeah, exactly. And then, of course, if you get lost in the command wilderness, there's always Docker help.
Like a compass and a map. Speaking of commands, let's get to the heart of Docker, images. We've all heard of Docker Hub, but how does it actually work in practice?
So Docker Hub is like a giant library, but instead of books, it's filled with pre-built software blueprints called images.
Right, images.
Right. So let's say you need to set up a web server really quickly. You can use Docker pull yanks.
And that pulls the image right from Docker Hub.
Yeah, and you'll have a server running in minutes.
No more messing around with installations and configs.
Exactly. And it's not just for downloading. You can share your own images too with Docker push.
So it's like open source software, but for whole application environments.
Exactly. Contribute to the global toolbox, so to speak.
So we've got our images. How do we turn them into running applications?
That's where Docker Run comes in. It takes an image and creates a container.
The containers, the actual building built from the blueprint.
Yeah, perfect analogy.
Yeah.
And then you can use Docker pups to see all the containers that are running.
So if I ran Docker pups, I'd see a list of all my active container buildings.
Exactly. And you can use Docker pups to see all the containers, even the ones that are paused or exited.
Gotcha. So what if I need to run a command inside one of these containers?
So for that, you can use Docker exec at container name command.
I could use Docker exec to check the files in my Nginx container.
Yeah, you're interacting directly with the container.
Okay, so what about stopping and starting a container?
You can use Docker stop, Docker start, and Docker restart.
Easy peasy. And to remove a container completely.
You can use Docker arm, but before you do that,
Check the logs.
use Docker logs.
Okay, what kind of information can we get from the logs?
The container logs show everything that's happening inside the container. Errors, debug output.
It's like a black box for your container.
Exactly. Invaluable for troubleshooting.
Okay, so we've covered pulling images, managing containers.
Mm-hmm.
What about creating our own images?
That's where we get into Docker build.
And that uses a Docker file, right? Like a recipe.
Yes, exactly. Each line in the Docker file is an instruction. And then you can use Docker tag to give it a name.
Like labeling your recipe.
Exactly. Make it easy to find. What about inspecting existing images?
Yeah. How can we see how they were built?
Docker history
Okay.
shows all the layers and commands, like a family tree. And then there's Docker inspect, which gives you all the nitty-gritty details.
Like an X-ray of the image.
Exactly. Configuration, networking, everything.
Okay. So we can see inside our containers, we can manage them, but they don't just exist in isolation, do they?
Great question. And that brings us to Docker networking.
How they talk to each other.
Yeah, how they communicate.
Okay, let's get those container departments talking. How do we see what networks are already running?
Okay, so to see the existing networks, you use Docker Network Lex.
And to create a brand new network.
You'll use Docker Network Create, give it a name, tell it what kind of network.
Like setting up a dedicated phone line.
Exactly. Then to connect and disconnect containers, you use Docker Network Connect and Docker Network Disconnect.
So we can control exactly who can talk to who.
Yes. And then to clean up any old networks, you can use Docker Network One Mori.
Gotcha. So we don't have a bunch of unused networks cluttering things up.
Right, good housekeeping. And if you want to see the details of a specific network, there's Docker Network Inspect.
Like getting a blueprint of the network.
Precisely. Okay, we've talked about how containers talk to each other, but what about their data?
Good point. What happens if a container gets removed? Is everything gone?
That's where Docker volumes come in. They're like external hard drives for your containers.
So even if the container goes away, the data's still safe.
Exactly. Data persistence. You can create volumes with Docker volume.
You can remove them with Docker volume rmember.
Right, but be careful with that one. You don't want to accidentally delete your data.
Good advice. And is there a command to see information about a specific volume?
You bet. Docker volume inspect.
Okay, cool. So we have these volumes, these storage units. How do we connect them to our containers?
We use the Daffy flag with the Docker run command.
Like assigning a storage unit to a department.
Precisely. So even if you recreate the container, the data is still there.
Clever. We've got networks, we've got data persistence, but we're dealing with a lot of containers here.
A lot of moving parts.
Yeah, we need a conductor for this orchestra.
You're right on cue. Docker Compose to the rescue.
Okay, tell me more.
Imagine you're building a web app with a web server, a database, maybe a caching service.
All in separate containers.
Exactly. Docker Compose lets you define and manage all those containers together using a YAML file.
It's like writing the score for the orchestra.
Yes. And then to bring the whole application to life, you just use Docker Compose up.
And to shut it all down.
Docker Compose down.
That's easy. What if we need to rebuild the images?
Use Docker Compose build.
And how about logs? If we've got a ton of containers, how do we keep track of the logs?
Well, you can use Docker Compose logs to see all the logs in one place.
Makes sense. So we don't have to look at each container individually.
Exactly. And if you need to run a command inside a specific container, you can use Docker Compose exec.
So I don't have to find the container ID manually.
Nope, it just works. And then there's Docker Compose lips to list all the containers that are running.
Docker Compose really is like a personal assistant for my applications. But what if we need to scale beyond one machine?
That's where things get even more interesting. We're talking about Docker Swarm.
Okay, I'm ready to swarm. So Docker Swarm is for managing clusters of Docker hosts.
Yes, exactly. Like a swarm of bees working together.
Got it. How do we start a swarm?
You use Docker Swarm in init on one of your hosts. That makes it the manager.
Like the queen bee.
Haha, sort of. And then the other host can join the swarm using Docker Swarm join.
And what if a host needs to leave the swarm?
They can leave gracefully with Docker Swarm leave.
So no drama when a bee decides to leave the hive. So we've got this swarm. How do we deploy our applications to it?
We use services.
Right, services.
We talked about those earlier. You define the image, the number of replicas.
Docker Swarm handles the rest.
Yes, it orchestrates everything. The command is Docker service create.
So if I want to run, say, 3 instances of my web server across the cluster.
I would use Docker service create replicas 3, my web server image.
Exactly. Docker Swarm would handle making sure those 3 instances are running across your swarm.
And to see all the services that are running.
Docker Service L is easy enough.
And to scale a service up or down.
Docker Service Scale.
So if I need to quickly add more web servers, I can just scale up the service.
Boom, done. Docker Swarm handles it all.
This is amazing. Docker Swarm really does make managing complex applications so much easier.
Yeah, it takes care of all the heavy lifting for you.
Okay, we've covered a lot of ground here. From the basics of Docker to the power of Docker Swarm. What else do we need to know?
Well, there are a few more essential commands like Docker login and Docker logout for working with Docker registries.
Right, Docker Hub.
Yes. And then there's Docker system prune.
For cleaning things up.
Yeah. Getting rid of unused images and containers.
Keeping things tidy.
Exactly. So those are the essentials, the foundation of Docker mastery.
Amazing. We've come a long way from checking our Docker version to orchestrating clusters. Yeah, we've just scratched the surface, though.
There's still so much more to explore in the Docker universe.
We'll get to that after a quick break.
Sounds good. I'm ready for more.
All right, welcome back. We've explored those core Docker commands. Let's shift gears and dive into Docker files. Remember, Docker build.
Oh, yeah, like blueprints for our containers.
Exactly. We're going to become Docker architects.
Ooh, I like the sound of that. Docker files are like recipes, right?
Yeah, each line is an instruction, like a step in the recipe. They're surprisingly human readable, even though they're orchestrating complex operations.
Okay, so where do we start with these recipes? What's the first ingredient?
The first thing you'll usually see is the from instruction.
So that's where we specify the base image, right? Like
Yeah.
what we're building on top of.
Exactly. You might start with something like Alpine Linux. It's small and efficient.
Or maybe something with pre-installed tools like Node.js or Python.
It all depends what your application needs. Think of it like choosing the foundation for a house. You wouldn't build a skyscraper on a foundation meant for a tiny home.
Great analogy. Okay, so we've got our foundation. What's next?
Well, now we need to start building. And for that, we use the RUN instruction.
Oh, UN?
Yeah, this is where you execute commands within the image during the build process, like installing dependencies, configuring things.
So we can run scripts and stuff right in the Docker file. That's super handy.
It is. You can do a lot with the RUN instruction.
Okay, so we've got our base. We've run some setup commands. What about like Files, config files, scripts, that kind of stuff. How do those get into the image?
We use the copy-y instruction. It copies files and directories from your local machine into the image.
Ah, okay. So if my application needs a specific config file, I can make sure it's included in the image that way.
Exactly, like making sure the furniture is in place before someone moves in.
Definitely don't want to forget the furniture. And what about environment variables?
Ah, yes, the env instruction.
So we can set those in the Docker file too.
You can. Think of it like setting the default settings before anyone moves in.
Database connections, API keys, all that good stuff.
Exactly. You can customize the environment without rebuilding the entire image.
Okay, we're building this fully furnished, containerized house. What happens when we actually run it? How do we specify what happens when the container starts up?
That's where the cmd instruction comes in. It defines the default command that runs when the container starts.
So if it's a web server, CMD would start the web server process.
Yeah, I got it. It's like setting the default wake-up routine for the container.
I'm really starting to get the hang of this. Any pro tips for writing these Docker files?
Well, one thing to keep in mind is the .dockerignore file.
Okay, .dockerignore, I have no idea what that is.
It's like a do not pack list for your container.
So you can exclude files and directories that you don't want in the image.
Exactly. Keeps the image small and efficient.
Makes sense. Any other optimization tips?
Well, another thing to think about is the order of your RN instructions.
How so?
Remember, Docker builds images in layers. Each RN instruction creates a new layer. If you change a lower layer, you might have to rebuild everything above it.
Oh, right. So it's like building a house if you change the foundation.
You might have to rebuild the whole thing.
Got it. So ordering those instructions strategically can save a lot of time.
Yes, absolutely. Docker can use cached layers from previous builds if nothing has changed.
That's a good tip. I'm feeling pretty good about Docker files now. We've covered a lot, but let's step back for a second.
Okay.
Why is Docker such a big deal? It's not just about the commands, is it?
You're right. There's a bigger picture here.
Okay, so what makes it so revolutionary? Why is everyone so excited about Docker?
Well, think about how applications used to be deployed. Dependencies could clash, servers would act up.
The classic, it works on my machine problem.
Exactly. Docker solved that by introducing containerization, packaging up applications and their dependencies so they can run anywhere.
Like shipping the application in its own little world.
Exactly. No more worrying about different operating systems or library conflicts.
So it's like Docker brought peace to the world of software development.
Uh-huh. Something like that. It made deployments more predictable and reliable.
Okay, so consistency is a big one. What else?
Well, containers are also very lightweight. They share the host operating system's kernel, unlike virtual machines.
So they use fewer resources?
Yeah, they're much more efficient, faster startup times, lower overhead, and you can run more containers on the same hardware.
Gotcha. That makes sense, especially for organizations who want to save money.
Exactly. Efficiency is a big part of Docker's appeal. But there's more. Docker also encourages modularity and scalability.
Okay, break that down for me.
Docker encourages you to break your applications down into smaller services. Each service runs in its own container.
Like building a Lego castle, one brick at a time.
Perfect analogy. This makes development and testing much easier.
And if one part of the application needs more power, you can just scale up that service.
Exactly. You can run more containers of that service without affecting the rest of the application.
That's really clever. Docker is way more than just a tool. It's a whole new way of thinking about applications.
You're absolutely right. It's a shift in mindset.
Okay, so we've got modularity, scalability. What about microservices?
Ah, yes. Microservices. Docker is a perfect fit for microservices architectures.
Remind me what microservices are again?
It's basically breaking down your application into small, independent services.
Like a team of specialists, each focusing on one task.
Yeah. Each service can be developed, tested, and deployed independently.
I can see how Docker makes it a lot easier. But managing all these independent services, that sounds complicated.
You're not wrong. That's where orchestration comes in.
Right, orchestration, Docker Swarm.
Exactly. And that's what we'll be exploring in the next segment.
I'm excited to dive into the world of Docker Swarm. It sounds like a powerful tool for managing these complex microservices architectures. Okay, let's jump back into Docker. We've covered so much: basic commands, Docker files, even microservices.
Yeah, we've laid a good foundation.
But there's one big piece we haven't really explored yet, Docker Swarm.
Right, and it's essential for managing Docker at scale.
Okay, so remind me, what is Docker Swarm exactly? Why is it so important?
Docker Swarm is Docker's built-in orchestration tool. You can manage a whole cluster of Docker hosts, like they're one system.
So instead of managing each host individually?
Exactly. Swarm makes it much easier to deploy, scale, manage those complex applications across multiple machines.
Got it. So it's all about making our lives easier when things get big. So how do we set up a Docker swarm? Where do we even start?
First, you got to initialize a swarm. You just run Docker swarm init on one of your Docker hosts, and boom, it becomes the swarm manager.
Okay, so one host becomes the leader.
Right. And then other hosts can join the swarm using Docker swarm join.
Okay, pretty straightforward. What if a host needs to leave the swarm? Like for maintenance or something?
No problem. They can leave gracefully with Docker swarm leave.
Okay, so no need to worry about disrupting the whole swarm if a host needs to step out. So we've got this swarm up and running. How do we actually deploy our applications to it?
We use services. Remember those?
Yeah, we talked about them earlier. They're like blueprints for how our applications should run.
Exactly. You define the image,
Yeah.
the number of replicas you want, any network settings.
And Docker Swarm takes care of the rest.
Exactly.
Yeah.
Distributes those containers across the cluster. The command for creating a service is Docker service create.
Simple enough. Let's say I want to run 3 instances of my web server across the whole swarm for redundancy and load balancing.
You got it.
Would I just use Docker service create replicas 3, my web server image?
Exactly. Docker Swarm will make sure those 3 instances are spread across your swarm.
And I can use Docker service sols to see all the services that are running.
Yep. And to scale a service, there's Docker service scale.
So if I need to bump up the number of web servers, I can just scale up the service.
Boom. Docker Swarm handles it all. Docker Swarm is seriously making my life easier. But what about security? When we're dealing with these big distributed systems, security's got to be top of mind, right?
Absolutely. Docker Swarm has a bunch of features to help you build and manage secure container environments. Like what? Give me some examples.
Well, for starters, you can control access to the swarm. Docker Swarm uses certificates for authentication, so you can restrict who can join, who can deploy services.
Like a security checkpoint for our swarm.
Exactly. Another thing is to make sure you're using trusted images. You can scan images for vulnerabilities.
Right, like checking the IDs of everyone who wants to join our party.
Exactly. And finally, you need to secure the communication between the swarm nodes. Use encryption, secure protocols.
Okay, so layers of security. So Docker Swarm helps us manage these big clusters, but where does it fit in with cloud computing?
Good question. Docker is a huge part of the cloud these days.
Is it?
Yeah, cloud providers like AWS, Azure, Google Cloud, they all have managed container services that work great with Docker.
So I could build my Docker images locally and then easily deploy them to the cloud.
Exactly. These cloud platforms have all sorts of features that integrate with Docker, like container registries, monitoring tools.
Makes sense. Sounds like the cloud makes Docker even more powerful.
It definitely does. It simplifies things and adds a whole new level of scalability and flexibility.
Okay, one last thing before we wrap up. We've talked about cloud, but what about serverless? How does Docker fit into that world?
Ooh, another good one. Serverless is all about running your code without having to manage servers.
Right, like AWS Lambda and stuff.
Yeah, exactly. And the cool thing is that Docker containers can be deployed to serverless platforms.
Really?
Yep. A lot of those platforms support Docker as a deployment unit.
So I could package my app in a Docker container and then deploy it to a serverless platform.
You got it. Docker and serverless are a perfect match.
Wow, that's amazing. We've covered so much ground in this deep dive. Basic Docker commands, Docker files, orchestration, the cloud, even serverless.
It's been quite a journey.
I feel like I've learned a ton. To our listeners, we hope you enjoyed this deep dive into the world of Docker.
It's a powerful technology with a ton of potential.
Yeah, and we encourage you to explore it, experiment with it, see how it can change the way you build and deploy applications.
The world of containers is waiting for you.
So go out there and get Dockerizing.